Hello and welcome to yet another video of Cornerstones of Math. Today we will solve the following problem. Suppose that constants a, b, c, d, and e are all greater than 1. Then we want to find the domain of the logarithmic function f of x defined as log base a of log base b of log base c of log base d of log base e of x. Alright, let's get right on to it. The key here is that when we are dealing with only real numbers, the argument part of the logarithm must be always positive. Using this, we can set up some inequalities. We have 5 logarithms in our function fx, and every argument of these logarithms must be positive. Therefore, we have, first, this part must be positive, so x must be greater than 0. Then this part must be positive, so log base e of x must be greater than 0. Then this part must be positive, so log base d of log base e of x must be greater than 0. Then this part must be positive, so log base c of log base d of log base e of x must be positive. And finally, this part must be positive, so log base b of log base c of log base d of log base e of x must be positive. So we have 5 inequalities of x, and the domain of the function is the common range of the solutions to these 5 inequalities. But here we only need to take a look at the very last inequality, since that is the inequality which gives the smallest range of x. So we have the inequality log base b of log base c of log base d of log base e of x is greater than 0. Therefore, this part, log base c of log base d of log base e of x, is greater than 1. Here, notice that this process is true only because it is given in the problem that b is greater than 1, making log b of x the increasing function. Likewise, since c is also greater than 1, we can say that this part, log base d of log base e of x, is greater than c. And we do the similar process. So this part, log base e of x, is greater than d to the power of c. And finally, x is greater than e to the power of d to the power of c. In case some of you do not know already, the stacked exponents are calculated from top to bottom, or from right to left. For example, the domain of the function log base 3 of 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 x is greater than 3 to the power of 3 to the power of 3, which means greater than 3 to the power of 27. And the domain of the function log base 2 of log base 3 of log base 4 of log base 5 of log base 6 of x is, using this result, x is greater than 6 to the power of 5 to the power of 4, which is 6 to the power of 625, which is approximately equal to this value. Now, some of you might wonder what would happen if the base of the logarithm is less than 1. In that case, checking out this video might help. Also, please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.